Hello and welcome to Dunjun. I'm Bill, and this is the series where we're documenting and demonstrating the process of making a game from scratch. Today is day 21, and in the previous day we started implementing Quaternions. So if you want to follow along at home, please go onto the GitHub page here, which is github.com/gingerbill/Dunjun, and then get the latest commit for will be day 20 if you're watching from day 21. Like so. So here we go. So go to the day 21 and do that. There's loads of all the stuff on the GitHub page, for instance, links to each of the episodes that have been recorded and uploaded, conventions that we'll be using in certain libraries, and so on and so forth. So if you want to learn how to write some of the code, just look on there and it'll tell you to. So let's get started. I have done some changes, nothing actually to the code, but actually I've added some new little helper batch files. So what I've done is I've included CLOC, which is Count Lines of Code app. It's an open source thing and all that lot. All it does is it counts the amount of lines of code I have in my code. So if I go into the command prompt here and go into where I'm storing Dunjun, that's CLOC, it counts all of the lines of code. And this means at this moment we have only 2,245 lines of code. So other things I've done is static check. So this checks to see if we have the word static anywhere present, and if we have where we have global variables. So this checks to see if we have the word static. Yep, we got them on the defines. Then this has got static casts and all that lot. So what I may do is actually change that and make it a space, so it only checks for static space. Let's go back onto there. Yeah, that's better. So only check now, it only finds, it still finds them. I'll just clear that actually. Static check. Yeah, it's still going to find the static cast ones. Doesn't matter for now, we can org that. And then it also finds all the global variables that I've kept, which we'll need to get rid of eventually. For instance, that's okay. So the other things is like to-do check. So this is just to find all the to-dos that I've written, all by me of course, because I'm the only person commenting to this thing at the moment. But yeah, it's to do all this. Most of these are from the image, one's from the image class, and all the rest from the Quaternions. And then just all the stuff here. Okay, that's fine. So let's get on with making the code. Now last time we implemented a Quaternion as a vector and as like a vector and a scalar, and we had them the opposite way round, mainly because in the shader. Now I'm thinking of changing this, not because we can make it go back to the way we think about it, so we've got the scalar and then the vector, or we could keep it this way round. It doesn't really make much of a difference. But what I am going to change is what their initial values are, and actually we're not going to use a vector anymore, because the problem is to get each of the parts, like W and X, if we want single X and Y's, we'd have to separate them, and we'd have to go to X, Y, Z, X, and it's a bit cumbersome to write. So what I'm going to do is, like with all the other stuff, I'm going to go and make a union, anonymous union, and put some anonymous structs in there for as well. So we've got a struct here, so we can have float 32s of X, Y, Z, and W. And I'll have another way of representing that data. Will be with, I could say, just a float vector of X, Y, Z of 3 of them there. Yeah, and we don't have to put W in because it's already there. Well, we could explicitly put it. And the other way we're going to do it, is going to do float 32 data, and that's going to be an array of floats, just like we have been doing with all the other conventions of the vectors. So like in vector 3. Where is it stored? Here. We're doing that. So vector 3 and all the different ways of writing it. So I'm going to put this and actually move it to where we normally have been moving it, which is after all the methods, like so. I'm just keeping with our conventions. That means our constructors need to be changed to include just the things like that. But we could just go... This should be, no, that's, I'm thinking of Sublime Text there. It's not working. Actually, if I go into Sublime Text, I've got it open already, and just do some coding in this rather than, doing the other thing. I don't know if this text will be small. I've changed this font size in Sublime Text and it's a bit smaller, so if it's hard to read, please go a bit bigger. There we go. Is that the correct size? Preferences user. Let's go to size 15. That's what we've been using in Sublime Text, so that should be readable. Whoops, go away. Where are we going? Include math, quaternions. Okay, so it's telling me X, Y, Z's not existing. I've got a linter on at the moment, and yeah, so what I'm going to do is do X, each of them separate. So X, and screw the vector bit. We're not going to keep the vector. We're going to keep X, Y, Z, or the data. That's all we're going to do for our. That could be Y. Oops. And that's Z. I can type much faster in Sublime Text usually, so it's taken a while because it's doing all the linting for me, and it doesn't like me doing that. So v.x, v.y, v. That, yeah. So what I'm going to do is remove the out of bounds stuff. So all we're going to do is return data index. That's all we're doing now. Changing that. So it will test for the out of bounds thing already for us, luckily. Next thing we need to do is copy paste that. So that's going to be X, that's going to be Y, and that's going to be Z. And that's just going to be X, Y, Z. We're going to do the exact same thing here again. Add another quaternion, so just, you know, it'd be easier if I just write X equals X plus B dot X. Copy and paste like that. Y, oops, Z, like so. I might have to delay the autocomplete a bit actually, it's a bit too slow, so it's a bit too fast for me. Where is the linter on this thing? User, there we go. Delay, let's make that about 0.3, I don't know, maybe it's probably not fast enough either. And the best thing about, I might change to Sublime Text eventually, just Sublime Text, than just using Visual Studio. But the main thing about Visual Studio is, the debugger is amazing, its integrated environment's amazing, and also for Windows, it's much better. But on other operating systems, I actually use just Sublime Text completely for doing C development. And I actually usually have, Sublime Clang on, but it doesn't work on Windows, and it especially doesn't work on Windows 8.1, or 8 in fact. I have got it working, but it doesn't work very well to me. So make this more efficient, not using the CrossProduct. Yeah, I do have, yeah, so okay, we've done that. But yeah, I'm just going to edit in this for now, because and then go compile in Visual Studio. It's a bit of a pain doing it that way around, but hey. I have got a more efficient one. I've already pre-written this, so it saves some time. I'm going to copy and paste it doing that. There we go, and that's in the wrong order, because this was from my old code and it's been used W first. Even though it doesn't really matter which way you do it round. Yeah, let's just do that. Okay. Y, Z. Okay, that's perfect. Oops. So is oops. Oh, I keep hitting the keyboard wrong. Lovely. So now I'm just going through the code and changing it for what I'm doing. So if I just, instead of doing that, data I equals b dot data. And the reason why I'm using data is that means I can pass this a pointer eventually. Now it's telling me that's not working, because I'm going to do it the long way around, just to be just as efficient. So x times x plus y times y plus z times z. That does note I'm going to keep the note in there just as a reminder. This is still not doing it correctly, so what I'm going to do is actually yeah, what I'm going to do is static cast as const vector 3's a. Why is that going wrong? It should work perfectly, that should. Why didn't you like that? I don't know why you don't do that. What was the other thing I needed to do? Yeah, we've got that. Also, I'd say also do the yeah, I'm not going to do those in explicit because they'll be exactly the same. So let's do go back to the start and just Q, and then we're going to do float 32 W, float 32, not W, X first. This is Y, float 32 Z, float 32 W. And all I'm going to do is copy and paste that. And then I'm going to go, oops, like so. And that should be SW there. I think I might want to do there is actually say that's explicit. Yeah, I will do that as explicit, so you can't put it as non-explicit. You know what I mean, if you don't know what we're talking about explicit stuff. Why can't I static cast that? Can I static cast .data? That should work perfectly fine. Oh, that should be B anyway. You know what? I'm going to do it like this, and it should work perfectly fine. Or maybe, actually I could do that way. Float 32 X, Y, Z. It's a float 3 array. That might work. So if I did A.xyz and B.xyz. Whoops. Do I have to do that? No, it doesn't work doing that way. We still have to do the cast to vector 3's. Well, actually, again, I'm thinking this as we go along. Let's create some actual helper functions for us here. So we could say the real part. So we could do it the same as, yeah. So we've got float 32, real part, right? Yeah, the scalar part. So the scalar part, that can do. I can just return the W. Copy, paste, ampersand, like so. There the scalar's done. And then what we got, we can have a vector 3 here. And then we could say vector const return xyz. Yeah, that could be a const as well, actually. Or maybe, yeah, that doesn't need to be a cast, that's just, yeah. Static cast, vector 3 of data. That should work perfectly fine, it's just not telling me it isn't. So what I need to do here is A vector plus B vector. Yeah, vector and scalar is a better way of putting it. So every place where it says x, y, z, replace with vector. That should get rid of most of the code errors. Except that static error, which shouldn't be an error, I don't think. Yeah, here we go. That's not a thing. Yeah, so that's just my test. Should compile still. Yeah, it still compiles. Perfectly fine. It's just Visual Studio doesn't... Not Visual... Sublime Text is telling me that's not allowed. I don't get you either. Yeah, that should work perfectly fine, and let's going to ignore that. Let's just ignore it. I could probably just do it normal standard C style cast. Will the C style cast still work? Okay, what it's telling me here. Oh, I didn't return it, did I? Whoops. It doesn't really make a difference, the static cast or the C style cast. There's no real much difference. Yeah, let's just get rid of that note. And keep that, yeah, we'll keep that note in there. Bill. I'll do it all in lowercase, it doesn't really make a difference. So keeping that note in there, and then we need to do the cross... Ooh, do we need a Quaternion CrossProduct? We can, it doesn't make much of a difference. Shall we make it? Yeah, let's do it anyway. Let's do this CrossProduct. Many of you may be thinking, what the hell is the CrossProduct in Quaternions? Well, it's pretty much, yeah, if you had two rotational axes, and you find the axis that was perpendicular to them, yeah, it's a little confusing, I know. Let's actually just get a new window up and just find that. Quaternion. Yeah. CrossProduct. Google's probably a better explanation. CrossProduct with Quaternions. Here we go. Quaternions. Here we go. Oh, all the Lie algebra and stuff. No, thank you. We don't need to talk about that yet. Quaternion product. Okay, that makes more sense. Yeah. So the cross product of a Quaternion, yeah, it does. It's kind of what I just said. It kind of gives you the direction, yeah, a direction between two Quaternions, which is perpendicular to both, like their rotations are wise. So if we can put it in, it won't harm anything. It might really. Quaternion, just copy and paste that, and then what we're going to do is return a Quaternion. And I've got a big load of code here already pre-written just to save some time. But that there, guys, is how you write the cross product in now why is it going wrong car const? You can't go const here. Oh, Quaternion, that's right, Quaternion, sorry. That's cross products, yeah. I know what I did wrong there, and that's Q1, Q... C... A... This is why I like linters, they're pretty nice. Because unless you're reading it through yourself, it won't work. Well, let's read through this code and explain what it does. So what we're kind of doing here is scaling... Yeah, it's the cross product. We're probably not going to use it ourselves. We might use it, actually, when I'm thinking about cameras. Yeah, because we're getting smooth cameras, that's what Slurp's for and everything later. So yeah, I was thinking about that. Well, that's apparently how it wants it to do it. I'm just going to say that, please. Oops, oh, I needed a comment size in it. The formats in Sublime Text is different. Anything else that we need to change? So things we need to add are the Quaternions to matrices, matrix to Quaternions, Euler angles to Quaternions, and then all of these functions here. Okay, to do rotate Quaternion around an given axis. That's going to be exactly the same as the other one. Yeah. So we've already got Quaternion to Euler angles. So let's do the other way around first. Euler angles to quaternions. Now how do we... Can we do that? I can't think how... Why... No, we don't really... Or do we? No, we don't need to worry about that. For now. Because we've already got all the pitch and the roll, so that's all you're doing is you're multiplying them in certain orders. And Euler angles... Oh, it's confusing, don't worry. Just thinking this through. Let's do the quaternions to matrix 4s first. Let's go back onto our faithful friend. I'm gonna see how better DuckDuckGo is actually. Quaternion to matrix conversion. Oh, DuckDuckGo is actually, last time I used it was about a few months ago, and it's looking a lot nicer. They've changed the style. They made everything left aligned now. It used to be central aligned. Oh, that's quite nice. Sorry, I'm not trying to advertise DuckDuckGo. It's not bad actually. Thank you very much. Here we go. That's what we want. It's a product of... Oh yeah, because I don't know if I've explained this, but quaternions can be expressed as 4x4 matrices. That's one way of doing it. And it's pretty interesting it that way, in my opinion. Because 4x... Again, this is one of the reasons why I use quaternions, because you can express them completely as real numbers of a 4x4 matrix. I don't know if I explained that in my previous videos, I don't remember. So we need to copy that. That's what we need to copy for our... thingamabob. What else have we not done? I may separate this out into the functions for now, but I don't know. Just looking at my code for now. Yeah, so what we need to do is do all the quaternion stuff. So let's do quaternion to matrix 4. So this is where we're doing it. So we're going to say inline matrix 4 quaternion to matrix 4 const quaternion A for now. So let's define a matrix 4 to begin with. That's what our result is. So mat return mat. It's a bit laggy. I think it's the linter that's doing the lag, because it's got loads of to-dos on and everything to do. So what is the... Is it tools, linter, lint mode? We'll load and save, save only. Shall we save only? That won't make much of a difference, will it? Just load and save will be okay. It'll just leave it as load and save. Definitely not background. Oh god, it'll be too laggy. It might be just laggy for other reasons, but yeah, so let's create some helper functions, because I know a lot of these here have got squared functions, and I don't want to keep writing that out. So what I'm going to do is create a load of squares and pre-squares and all that lot. So we're going to do all that, so that's going to be a.x times a.x. How many times do you get... Is there a w squared anywhere? No, there's no w squared. So that means we don't have to worry about that one. So that's going to be YY, and that's going to be ZZ. Oops, wrong way around. Like that. YY, ZZ. Let's do the other ones as well. So they've got an XY, an XZ, and all the other combinations that we could have. So we could have XY, A dot X times A dot Y, const float 32. So AZ is another one you could rewrite. So A dot X times A dot Z. And remember, these order of the multiplication doesn't matter in doesn't matter at all for scalars, so you don't have to worry about that. Y dot Z is the other one. Oops, Y times A dot Z. Again, I'm not putting the spaces in here just because I could do that. There we go, it's formatted it for me, lovely. And then the other ones is all the W ones left, because they've got some W times things here. So W X, A dot W times A dot X, copy, paste, paste, Y, Z. Okay, let's do each of the matrices. So make sure this matrix first is an identity matrix. I know it is by default, but I'm just going to say that is what it is by default. So this 0, 0, 1, so mat 0, 0 is 1.0f minus 2 times, and then that's 2 times, and then I'm putting brackets because it's minus 2 minus 2. I'll make this a bit bigger if you can see it. Is that better for you? Yeah. So we got yy plus zz. Let's go to the next line. So x0, 1. So that's 2 times xy wz. So that's what I'm going to want across, yeah. Is that right? Yeah, plus wz. So no, I'm sorry, it's go down the column, isn't it? They're in columns. So it's yy, yeah, plus wz. So do that one. That was 2 times xy plus wz. And the last column, last row, is 2 times is xz minus wy. So let's do this for every other one now. So the next line, so this one. So map 1, 0. So that's 2 times 2 times xy minus wz. Mat 1 of 1. This is 1 minus 2 times xx plus zz. And then mat 1 of 2 is 2 times, doing the times again, oh, was it yz plus wx. Yeah. And then the last column that we need to worry about, that's 2 times I can't type. I never do anyway on these bleeming videos. I can't. I'm trying to read off the screen while I'm trying to type, and it's multitasking. Mat 2, 1. So that's yz minus wx, and then the last one is 2. 2. 1.0 minus 2.0 times xx plus yy. And I've got, again, the reason why I've done this is a mild bit of optimization, but it's not, it's just so I don't have to keep typing. .x, a.x times a.x, it's just a shorthand as well. And it is a mild optimization, only a mild. Okay, so, because I've used that 9 times and there's 9 of them, so yeah, So let's turn it into product of matrix 4s, but when you do it, you get the same as what I'm doing here. That's exactly the same thing that happens there. As you can probably see what happens. There's other methods, issues, yeah, I'm going to assume it's normalized, so yeah, that might be a good idea. Yeah, I might just make that all, yeah, let's leave it as A, make that as Q. So this assumes it's normalized, okay. So in the, whoops, so that means quaternion A equals normalize Q. So you've got to assume it's being normalized, but I'm not going to assume that, I'm going to do it normally, explicitly. Let's look some code here. Oh, they've done square W, that's what they've done. Yeah, I don't need to worry about that. Now, matrix to quaternion. Again, this is a bit more complicated to do. I made this again. I'll leave this later. We won't need it anytime soon, I don't think. Quaternion to matrix makes sense, but matrix to quaternion we don't really need, and it'll only work if it is only a rotation matrix. I don't really like doing that, to be honest with you. But okay, let's do the next. So there's lerp, and I might actually make that into a function itself. So in the functions, and I might put this in here. So, oops, just thinking about it. Actually, let's do it with this. Add new item. Interpolation. That's how you spell it, right? Yep. Let's see, let's save that. Let's go back into Sublime Text and do it now. Yeah. Yeah. In Dunjun, math, functions, interpolation, header. Oh god, that's a long, long list. But luckily, I don't want anyone to call that. I just want to call them that. Interpolation. So these interpolation ones, let's put this full screen again. Let's go to do it like that. Namespace. Actually, there's a shortcut, isn't there, for that? I made a little snippet. Do that. There we go. Namespace Dunjun. So what we need is mix, lerp, slurp, and squad. So what I need to do is include Dunjun, math, Quaternions. I'll also include Dunjun common, just for all the other things anyway. So let's do inline, and we'll do lerp first. And this is going to be a template function, mainly because we can express this in many different ways. And actually, we'll need two different types, won't we? Oh, damn it. No, I'm going to assume everything's float 32, to be honest with you. That's not a bad assumption to do, in fact. But what you'll need is const t, x, const t, and that's y. And then we're going to have const t, and that's what t is. So that's what lerp is. And I'm going to... Have I got a cert? Oops, common. Have I got a cert stuck in there? No, I haven't got C cert in there yet. And I might make a define for a cert as well, so we can get rid of it later on. Yeah, I might define the static assert as well. I know, but is it a standard assert, isn't it? Standard assert T. So that might work if I do that. So assert. Yeah, it does work. Cert that T is greater than 0. And we're also, and T is less than or equal to 1. So we're going to make sure it's within those bounds, otherwise you're not asserting it anymore. Can we do... Well, that's why float 32. That should be a float 32. That shouldn't need to be const, does it? You're not going to pass it. It's not going to be... Yeah, not going to do that define. It doesn't work. I swear it's a standard define though, not just a cert. Is it? We've only got like 10 minutes left of this video. Wow. Oh, is it standard assert or is it just assert? Oh, the internet's slow today. It's probably not C++ reference. It's not usually. I don't know. They're all about the same, really. It's not. It's just assert. There's no standard assert to it. No, it's just assert. There's no standard bit to it at all. I'll leave it as that. I won't put a define because we can just define it the opposite way, can't we? So next, I'm just going to return the standard definition for it. A? Why am I using A? It's T. I'm thinking wrong there. It's T for the T parameter. This is what slurp is, and again, it's a template. You should try and not use templates at all, but yeah, sometimes you have to. Okay, next we need to do is slurp. Now, how we defined it before in the previous video was just check up on that video if you want to see how to do it. But I'm going to just implement it now because I think I can remember. So what I'm going to do is create a new variable, Quaternion, and it's going to be y. Yeah? So it's just as a temporary variable, because I don't want to change it. Yep. And then what else I'm going to do is we're going to get the cosine theta of the angle. So we're going to dot product the two of them together. So this is the angle difference between them, yeah? It's telling me I'm going wrong, so I'm just going to return... do I need Z? Thinking about it? Yeah, I do need Z. Because what I'm going to do is this. So if cosine theta is less than 0, so that's what I'm testing there, is if it's less than 0, so the angle is below, yeah, you can see what I'm talking about. We're going to make Z equal to negative Y, and cosine theta equals negative cosine theta. So we're just flipping it to make it work. Next is we're going to check if cosine theta is I'm trying to think. Thinking about this, is cosine theta, it'll always have to be less than 1 because that's what it'll be. But if it's ever greater than 1, we need to check for that. So if it's greater than 1, because sometimes it can be, that means you've got an imaginary thing going on, completely imaginary thing, a completely imaginary angle, which is possible with this stuff here. We need to do to do handle. Cosine theta, yeah, it always has to be imaginary angle. And then what else to do is just, we're going to go here, so float 32, the angle, I'm going to say, I could do a radian, but it's not, just leave it as that for now, just leave it as a float 32 just for ease of use. And then what we need to do is we need to include standard math as well, don't we? So include C standard, C math. Like so. So what we need to do is a cosine cos theta. And then what we're going to turn is new Quaternion. But how we're going to do it? Oh, I remember how we did it now. So if we do, let's say that's the result. Oops, return result. What we needed to do was have a new result, which we're going to do. So, we don't need to do a result, actually. Well, we can do. Doesn't make a difference. So result, this is just for debugging purposes, why I'm splitting it up. What we said was it was the sine of 1 minus t. Is that what we kept the parameters to be? Yeah, t, yeah, just checking. Times the angle. Times x. Yeah. Plus sine. should be a standard sign actually. Standard sign of t times the angle times z, like so, and that's all divided by the angle. Actually, let's not do division. Let's do let's do multiplication. So multiplied by 0.f divided by standard sine of the angle. That's how we did it before. Slurp between two of them. That's not overloaded, and I remember why, because we don't want to do that, do we? Oops. Ooh. I'm pressing control, but I didn't know that was a shortcut for Go Sublime. Ooh. The more I learn, the more I learn. That's pretty interesting, yeah. That's formatting in a way it says it thinks correct. To do, handle imaginary angle. So now we need to handle imaginary angle, and we need to create a new function here, and it's going to be called mix. Now, for most cases, mix is going to be exactly the same as lerp. However, for quaternions, it's a little bit different. So mix, and then I'm going to take the same bit here. What we do is going to mix two quaternions together. That's what, again, that's what it says. I'm going to do the same again. We're going to say float 32 cosine theta equals the, equals the dot product between x and y. Yeah, as soon as we've done this, we should have done most of this. I'm not going to do squad. I'm not implementing it. Not because I'll implement it if we need it. We may need it. What am I doing if? So mix. Mix is the same as us writing lerp every time. So if we go back, yeah. So for okay, so I'm going to do that. So if cosine theta of those two angles there. Oh no, wait, I'm just thinking this. I don't need mix. It's lerp, isn't it? That's what that is. Yeah, I'm just thinking it through. I'm looking through my notes, that's all. If that is greater than that, what we're going to do is get a return result. We're going to do another one of these result things. Just don't have to keep creating it and do that there. Yes, we do that, and then what I'm going to do is result now equals a quaternion of, we're going to lerp all of the different values together. So x w with y w and t, we're going to do it for all of them. It shouldn't be w there, it should be that should be z. You know what I mean? It should be x. It should be x. Oh. I'm thinking it the wrong way around in my head, and it's not a good thing to do how I've implemented it. Again, and a lot of you will be saying, why didn't you just change it? It'll be much easier for you. And I know it probably would be to think about it. It's going to tell me that is the correct way to format it. Yes, it is. Good. So we've implemented all the things we want without implementing anything else. The only thing we've got left to do is that. Do we want it or not? We've got the quaternion to matrix for. Rotate quaternion by an angle given around a given axis. Rotate quaternion. We've already got axis angle. But what I'm thinking, the reason why I put that down was so to just say, here's a quaternion, rotate it, and here's another quaternion out. Instead of creating that quaternion, create an axis angle and do that to make it a bit more efficient. That's what I'm thinking it is the logic. Yeah, angle axis, axis angle, whatever. Yeah, because I've got, if I go into the matrix equations here, we've got a rotate here. And this is an angle and a vector, but it produces a matrix 4. I think if we do it the other way around, it'd be a bit ambiguous. So let's just leave that for now. And that should be the end of today's video for today. Yeah, save that. We've got all that done. So in the next video, I think we can get on and start creating our own transform class now. And not be touching matrices at all, only for cameras. That's the only thing we're going to use matrices for, is cameras. And we're going to have our own transform class, which will handle everything, and we don't have to touch a single matrix ever. So stay tuned to that, and goodbye.